Thank you, everyone, for joining today's webinar on the BAO Analytics Platform. My name is Catherine Liu. I'm the Director of Business Development and the Analytics Platform Product Lead at BAO Systems. I'm joined by my colleagues today, Lars Overland, who is our Chief Data Officer and the Analytics Platform Engineering Lead, as well as San Garman, who is our Head of Data Science team. So you guys will hear from them a little bit later throughout this presentation. In terms of sort of the schedule for today's webinar, first we'll give a really brief background on BAO Systems for those of you who are not familiar with us. And then we'll talk a little bit about how we came to where we are with the analytics platform and what drove us to develop the analytics platform and how we see it being used for programs and countries. We'll provide an overview of the platform and a demo so that you guys can actually see the functionalities and see what it looks like yourself. And then we'll talk a little bit more about how we can provide help to organizations such as yourselves in order to use the analytics platform. So a little bit of background about BAO Systems. BAO Systems, as a company, our goal is to make high quality data available, accessible, and digestible through our expertise, the services that we offer, and the products that we developed. We have a multidisciplinary staff, and we think that combined we really help to understand the needs that organizations have around data and really develop solutions that will drive impact in our programs. In terms of our company, we comprise of public health practitioners, health information system specialists, data scientists, software engineers, and systems engineers. And we work together in order to provide the highest quality services and develop meaningful products. We offer a range of services that range from data collection to data management, integration and interoperability, and advanced analytics, which we'll talk a little bit about today. And we also develop a number of products, including Dharma Platform, which is an on-the-ground data collection tool that allows organizations and individuals to quickly spin up data collection tools anywhere, anytime. The BAO Analytics Platform, which is a subject for today's webinar, we'll talk more about throughout the presentation. We also have the BAO Integration Suite, which is a suite of tools that allow for system-to-system data exchange, whether it's upstream systems of DHIS2, including ODK or Kobo, Google Sheets, OpenMRS, and others, DHIS2 to DHIS2 integration, and then being able to get data out of DHIS2 into other systems and advanced business intelligence tools like Power BI and Tableau. We also provide a range of DHIS2 hosting and support services using AWS Cloud, and ensure that your data are secure and protected according to local and international guidelines. As a company, we've worked with over 100 different partners, or partnered with 100 different organizations that are present in over 70 countries around the world. Currently, we host over 300 individual instances of DHIS2, and again, the support that we provide are either with NGOs and ministries of health alike. In terms of our approach to using data, we really see this as an opportunity to maximize data flow from the point of data collection all the way to the point of use. And we do that leveraging technology solutions. And so what we want to do is to help our partners quickly collect the data that they need on the ground, enable offline and real-time tracking, being able to stream those data into a scalable warehouse, integrate data sets from across different systems and tools so that organizations and decision makers can really evaluate those insights more holistically. And so our analytics platform is just one of the ways in which we see ourselves supporting this flow. So how did we get here? Why did we develop the analytics platform? What are the challenges that we see? Shown here on this slide are a number of challenges that programs face in terms of effectively and efficiently using data to drive programmatic decision-making, as well as to evaluate the impact of programs. Data use goals are often not clearly articulated or linked to specific actions, and this is really looking at why are we collecting data in the first place? What decision will we be able to make by collecting these data, or are we just collecting data merely for reporting purposes and not actually using them? Data are not often available or accessible in a timely manner to decision makers when they need it, and so the process of data collection, cleaning, transformation, and analysis is often largely manual and time consuming. And as many of you guys know, M&E staff repeatedly spend days to weeks curating programmatic data. And by the time the data are actually ready for interpretation, the data are already outdated. Another challenge to data use is poor or questionable data quality. I think oftentimes in a manual system, transcription processes often introduce potential errors around data quality which further reduce the trust in our data. And so if we can develop solutions and processes to automate some of these data transfers and reporting processes, it's at least one way in which we can help improve the quality of data collected. One of the biggest challenges that I think a lot of us are really facing now is the disparate data systems and limited interoperability between these systems. Oftentimes, a data element in HMIS doesn't necessarily align with what that particular data element or how those data are collected in a supply chain information system or a human resource information system. Staff time spent transforming and manipulating data in order to prepare it for analysis and to really make sense and identify that one particular facility with one nomenclature and one system is equivalent to another facility name in another system is a time-consuming process. And it oftentimes presents challenges when our analysts are trying to look at the data and understand how supply chain systems may link to actual drug delivery and usage of those services. And data are, as a result, often analyzed in silos, which really leads to decision-making occurring in silos. In terms of capacity to perform and consume analytics, I think that there's a huge range with which capacities exist within a country or within an organization. And many of our programs are still facing challenges in terms of being able to move beyond descriptive or diagnostic analytics and start to be more predictive around what they should be expecting to see in a given reporting period and comparing that to what is actually observed. In terms of financial resources, that's often one of the biggest challenges, right? Is everyone says, or everyone agrees that digital solutions and digital technology to alleviate some of these challenges would be great, but we just don't have any money. And so one of the things that we really want to think about as a company and what we struggle with in order to provide the best support that we can to your programs is really developing a cost-efficient solution that can be scaled across a project, across an organization, and across a country. So shown here is guidance that came out from WHO earlier this summer in light of the COVID-19 pandemic. Health systems around the world are being challenged by increasing demand for patient care, not only for those with COVID, but it's also being compounded by the fear, stigma, and misinformation, and the limitations on movement that have led to disruptions in delivery of essential health services. I think we've seen here in the United States how initially at the start of the pandemic, a lot of essential services were delayed, or the type of services that one could receive at a health center or a hospital or a doctor's office. It was really limited to what was considered to be essential. Any system's ability to maintain the delivery of these essential health services depends on the baseline burden of disease, local COVID transmissions, and the health system capacity to react to the pandemic as the system evolves and the transmission evolves. As demands on the systems have surged, many of our health systems have had to adapt in order to come up with better ways in which to ensure that essential health services are being maintained to maximize the benefit on populations in general. So looking at the list of operational guidance and strategies recommended by WHO, you'll notice in bold, one of them is to strengthen the monitoring of essential health services. During today's webinar, we want to demonstrate how the BAO Analytics Platform can be utilized to not only advance analytic capabilities to improve monitoring of essential health services during the pandemic, but also how these lessons can be applied more broadly, so beyond the pandemic. What are the ways that we can improve monitoring of essential health services and get meaning out of our data? So over the last 10 to 15 years, implementation and scaling of DHIS2 has significantly improved data access, availability, and its use. Many of you guys are DHIS2 users, and many of you may even be DHIS2 experts and have firsthand experience with how DHIS2 has improved your own data use within your project, program, or country. For many of our programs, monitoring essential health services starts with programmatic data and visualizations offered within DHIS2. And in this case, we're showing publicly available data at the site level from PEPFAR on PMTCT data through 2016 through Q3 of 2020. Now, if I switch, excuse me. Now, looking at these data, you can see that if you look here in this initial line chart, and again, I'm just showing a static version for speed's sake. Looking at PMTCT data, we can see that there's a fluctuation that seems almost seasonal, where you have troughs and peaks, and that there is some seasonality to the data. When we're looking at sort of the latest quarter, it becomes challenging to see whether or not what we observe in the current reporting period or the last reporting period is actually reflective of a seasonal trend, or whether or not there actually is something happening. You can see that there's sort of a dip here. Is this really a decrease in services that were provided, or is this just part of the seasonal trend that we're seeing? And I want to pause here just to make note that these data that we're showing in a DHIS2 dashboard, that these are publicly available PEPFAR data that we have downloaded from PEPFAR's public-facing website. And so these data are available and accessible to anyone, and we've simply taken those data in a flat file and ingested it into a DHIS2 instance to mimic the type of data that many of you guys see within your own programs. When you look down here to these line graphs at the bottom, what we're really looking at is overlaying sort of the quarterly trend in data year on year. So right here shown in green, you see for PMTCT positive, so the number of women that test positive during their pregnant women who test positive for HIV. You can see data here from April to June of 2020. And you'll see that in general, that during this time period, that it is actually normal to see sort of a slight decline in the number of women who are testing positive. And then normally we would expect to see a slight increase or a fairly sharp increase in the number of women testing positive. Now, I'm not making any allusions as to why these observations exist and what's really going on within the programs. But one of the things that we wanted to point out is that within DHIS2, at least with the current analytics, looking at sort of this trend alone, we want to better understand whether these results deviate in 2020, whether or not they actually deviate from the historical trends, or whether or not we're in fact seeing a larger decline in service delivery than what we should be expecting. So hold on to that thought for just a minute, and really this is what's driving us to sort of develop a product that would advance our analytic capabilities. And again, this is sort of acknowledging the many limitations that we face within our DHIS2 instance. And so our vision was really to develop a product that would transform our partners' ability to analyze data and to generate more meaningful insights within their data. And so this is what really led us to develop and conceptualize the analytics platform, where we envisioned the ability to ingest a variety of data sources, regardless of where those data sit, whether it's programmatic data, program financial data, and whether it's pulling data directly from a country in their HMIS or other information systems. And then to actually bring those data together with the wide variety of public data sets that exist out there that are available for use, but are often not used or used in silo. Once these data are ingested and merged and aligned together, to really create and build out a catalog of information that's useful for programs to use, and have a place where we can store the data for advanced analytics, machine learning, and just the ability to really co-analyze these data sets together, and then have those data available to any number of visualization tools such as Tableau, Power BI, ArcGIS, or a number of other open source visualization tools such as Superset and Metabase. And so with that, we developed our analytics platform, the BAO Analytics Platform, which offers these features to effortlessly ingest data from a variety of sources, will allow you as a user to access a large number of public data sets that are already available, but you may not know about or know how to access, or want to have to go through the process of finding all these data sets that might be useful for your own analyses. The ability to explore, predict, and generate alerts on the data. And then again, to connect to a variety of business intelligence tools. In terms of the core features of our analytics platform, we offer a user-friendly interface, which you'll see in much more detail in a few slides. One-click ingestion of public data sources and the ability to ingest through a user-friendly interface to a number of data systems and popular systems and tools that you guys are already using within your programs. Logging and alerts on system failures, data set level access with individual user accounts. Obviously, many of you guys are accustomed to the very granular permission and access levels that are offered within DHIS2, and we acknowledge and wanted to build a system that would allow people to have a similar level of access control to specific data sets. And so whether it's by country, by subject area, or health topic area, or whether or not only a certain number of individuals are allowed access to financial data, which are often sensitive in nature. We'll show you how we can use SQL statements to perform transformations and advanced analytics on our data sets within the analytics platform directly. We offer a rich catalog in which we enable users to set schemas, to provide profile details around the data set itself, and so a description of what the data is, who the data are, the time periods with which the data contains, as well as the ability to tag your data set. And so if you want to tag it with HIV or finance, agriculture, etc., really offering a rich ability to tag your data and then to search based on any number of parameters. We also offer the ability to join and parse data sets. This has been really useful for DHS survey program data, which when you connect through the API offered by the demographic and health survey data, the sheer amount of data produces millions and millions of rows of data, and this just isn't feasible for any user to sort through all of those data in any kind of visualization tool. And so using our parsing abilities, you can actually create subsets of the DHS program data and make it more user-friendly for our analysts. And then again, connection to a number of BI tools. In addition to our core features, we also offer a number of custom features that can be developed on demand and as are needed. I mentioned the library of data sets. So showing here is just a collection, not our entire public data set library, but a portion of our public data set library. And so you'll see here that we naturally have a lot of data around COVID, but we also have data around from the WHO Global Health Observatory. We have, like I mentioned, the demographic and health survey data. We have master facility lists for sub-Saharan Africa, data from the World Bank around rainfall, and population level data, because we know that one of the more critical things in terms of analyzing data is really being able to create that denominator and knowing what your total population is. So what we're going to walk through, and cognizant of time, what we're doing today is to walk you through how we've used the analytics platform and the proof of concept that we're developing and working out, in which case we've taken the HIV data that I showed you earlier, that is publicly available and is PEPFAR data, together with COVID data that we are getting from Johns Hopkins University on a daily basis on the number of individuals that are testing positive for COVID, and streaming those data together into our analytics platform and replicating and conducting analysis in Power BI. And so I don't want to go too much into the details of actually analyzing the data, excuse me, but what I do want to show you is that we've been able to do what we set out to do, which was to look at data, use some advanced analytic tooling by programming some stuff directly within the platform to create this indicator, this value, this data element called value difference, which actually looks at the difference in any one indicator or data element from one reporting period to another, and to see whether or not that value difference actually shows us anything. And this is really to identify whether or not what we see in the last reporting period is abnormally high or abnormally low based on historical trends. And what you can see here is that looking at this dark line, which is the value difference, that we are actually seeing lower than expected results in the last quarter. And so this aligns with the hypothesis that potentially that some of the decrease in services that we are observing may be a result of the COVID pandemic shifting up. In addition to those advanced analytics, what we're also able to do is to look at COVID data together with HIV data. And so what you're seeing here on a dashboard is simply just that on this one single dashboard, we have COVID data represented, we have HIV data represented. And what we want to be able to show is that while you're starting to see a decrease in service delivery, you are actually observing an increase. I'm not showing this live right now, but certainly can switch over to this where you have an interactive visual where you can see that, for example, in South Africa, we're actually starting to see a bigger change in the value difference in South Africa compared to some of the other countries. And this corroborates with our hypothesis that potentially this could be due to the pandemic, as we know that South Africa has been much more sharply affected by the COVID-19 pandemic than many of the other countries in sub-Saharan Africa. With that, however, I'm going to actually turn it over to Lars, who is going to walk us through the analytics platform directly.
So thanks for that nice overview. So I think What I'm going to do now is to just show you a little bit of what we've been doing so far with the analytics platform, and give you a demo of kind of the basic features that we have so far. So really at the heart of the analytics platform is what we call the data catalog. So the data catalog is really kind of a central inventory of data sets. So this is a single place for everyone to go and discover and look for and explore all of the data sets that the organization has available. So as you can see here, we have been ingesting a number of data sets. We have public data sets, as Catherine referred to. We have sort of custom uploads from CSV. We can connect dishes to instances and so on. So again, like this is where all of the data sets will end up after you've been ingesting the different types of data sets. To connect more data sets, we can click on the Connect Data button here in the top right corner. That will take up the menu where we can pick from the different types of data sets that we have. So as you can see, we have CSV file uploads. There's DHIS2 connector. There's all different databases that we would like to or want to connect to. There's the public data sets and so on. So this is kind of the starting point for connecting data, and we're also working on other types of connectors. For instance, we're working on a ComCare connector now to be able to bring in data from ComCare. So, for instance, if you have a kind of a CSV file that you would like to ingest very quickly into the platform, all you have to do is to click on the CSV file upload. You can give it a name. So let's say I have some data related to immunization. I can give it a name. I can give it a description. I can say who is the owner of the data set. I can add tags. So we have a feature for tagging data. I can select from these. And then I can select the actual file that I would like to upload. And I click Create. And this will now take the data set and ingest it straight into the platform. As you can see here, we have the name, we have the description, there's tags, there's different types of metadata around the data set. So there's the owner created by, last updated by, a little bit about the status of the data set. If I click on data preview, we can see now that we have I think there's a top 50 rows of the data set that we can browse to get an idea about what types of data is in this data set. I can click on the data structure tab. That will give me the basic structure of the data set. So as you can see here, the system can automatically detect different types of fields and columns in the data set. So we have data, facility type, organid, value, and so on. We can see the distinct values, number of null values, min and max, data types, and so on. And all of this is automatically detected by the system. Yeah, so this is how easy it is to ingest sort of arbitrary data sources into the system. And this can then immediately be explored from BI tools such as Power BI and Tableau and so on. So going back to the data catalog, we can, of course, search for different data sets. We can scroll down and kind of browse the contents of the catalog. Let me have a look at one of the public data sets. So Catherine mentioned that to connect different types of public data sets, we can go to Create and click Public Data Set. And this gives us the available public data sets that we can ingest into our data catalog. So this is kind of the shared catalog of publicly available data sets that BAO is curating. And with a single click, I can click on data sets, I can explore it, and I can click Connect. And that will bring that data set straight from the catalog into the data catalog for my organization, meaning it becomes available for analysis, and we can then join it with other types of data as well. Yeah. So by clicking on one of these, we can check one of them out. We can have a look at the demographic health survey data. So let's click on this one. You can see here that it was ingested by Sam. We can preview the data. We can have a look and see, get a glimpse of what the data set contains. We can see the data structure, again, fields and data type, distinct values, and so on. And we can also look at the change log. And the change log will show you basically what has happened with this data set. So, when was it ingested? When was it last updated? Was there any errors around the data set, and so on. Moving on, so we also have connected to a DHIS2 instance. So we have connected to a DHIS2 instance called data.baosystems.com. that currently contains data on COVID-19 and also HIV data. And again, we have the usual preview and we have the structure. We also have what we call SQL transformations. So as Catherine referred to, we have the ability to transform the data using SQL in the data warehouse. And this is proven to be a very effective way of transforming data. So instead of writing, lots of complicated code and basically hiring a data scientist or data engineer, you can now do transformation just based on SQL, which is then run in the data warehouse. So SQL statements like this can then manipulate and transform the data set according to your needs. So that's what I mean with that is, mapping the data to different kinds of coding lists. It could be enriching the data. It could be joining the data. It could be filtering the data and those kind of things. So this is a very simple and effective way. It's, a lot of people know how to write SQL statements to transform the data set. Again, you have the change log to see what's happened, like how often was this ingested. This can be ingested on a routine basis, so we can connect every 15 minutes, every hour, every day, every week, and so on, which is of course can be then scheduled to run, so we don't have to do it manually. If you look up in the right corner here, we can see that we have a range of options. We can of course edit the details. So if I would like to add, more tags or change the name, change the description, change the refresh schedule, and so on, I can just come here and do that. We have also the ability to change the connection information to the database, to the web API of DHIS2, do different types of data type selection, and so on. We can also refresh the data manually if you want. We can download the data. So if I would like to take this data now and download to my local computer to do more analysis in desktop-based tools directly, I can easily do that by going to the download dialog and click on these files. I can also share the data. So if you would like to give access to this data set to specific people, I can also easily do that. So you can control this data set by saying it's private to myself, it's shared with specific people, or it should be accessible to all users in my organization. So here I can come and I can search for people. I can search for Catherine, and I can say, okay, I want Catherine to have access to this data set. And then when next time she connects to the platform, she can then see this data set. So this is a nice way to kind of to provide access control within the organization. Yes. All right. We can duplicate the data set, and we can, of course, also remove this from the data catalog. Right. So moving on, we also have the ability to write views. So views basically mean SQL views, SQL statements or queries, essentially, on top of different data sets. So if you have the need to create complex joins between data sets or complex filtering of a data set, and then easily make that accessible to other people, other users in your organization, you can do that through views. So one very simple view would be this one. We can write a view on top of a COVID data set to just filter data for one country. And then we can create a view out of this, and then we can essentially then make this available for analysis by other people in the organization without these people having to understand SQL, sorry, SQL or how these different data sets are combined. Excuse me. And then we have another one here, which is also a simple one, I think, a very simple one here. But the point again is that we can write as complicated SQL views as we want. We can go and create, and we can give it a name, description. You can select one of the schemas, and then we can write an SQL query that can potentially join, filter, and aggregate different types of underlying data sets or tables. Yep. Finally, we have the schemas. So a schema is basically a way to group different data sets. So if you would like to have, kind of logical groups or namespaces across different tables and data sets, a schema is the way to do that. And if you look in Power BI or Tableau or other tools, you will see that this provides kind of a nice way to group related data sets and tables. So if you would like to improve the organization of the data warehouse, you can do that through schemas. So you can see here that schema basically has a name, and then when you create data sets later, we can pick the schema that we would like to ingest the data source into, so we can keep better organization of the platform. We also have the connection information. So this is the information you need when you connect from different BI tools. So these kind of dialogues for connecting to Redshift, which is our underlying data warehouse, is very similar across the different BI tools. So they typically ask about the host name and the database name and the username and the password. So this is what you enter then to access very easily the data in the platform. And the cool thing is that the password is the same as the account that you log into to the BAO Analytics platform, so that there's no kind of secondary password that you need to remember or maintain. This also avoids to give out kind of a organization-wide account, so that everyone is basically using the same username and password, and then you have to give out basically full access to your warehouse to everyone. This allows people to have individual accounts that can have access control, and you can revoke an account if it's compromised, and these types of things. So that was the quick overview. I can show you super quick. So this is now Power BI service in the cloud, and this is like now looking at some of the data that you have ingested into the analytics platform. So as you can see here, like all of the data quickly becomes available. This is based on a DHIS2 installation, and you can see here that all of the different names and dimensions and data values and so on from DHIS2 becomes available directly in Power BI. So you can play with the data. Even the dynamic dimensions that you create from DHIS2 will come through and allow you to do analysis based on the dimensions that you have set up, for instance, in DHIS2 or other data sources. Yeah. So I think I'll stop there, and I guess we can do questions towards the end. Yeah.
So I'm Sam Garman. I'm the head of data science at BAO, and so I'm here kind of representing the analysts. So I'm the person primarily right now who is a user of the analytics platform, and so Catherine and Lars have shown our starting point for the platform, helping us centralize data, integrate it, enrich it with other data sets, our programmatic data with other data sets, easy access to your favorite BI tools. And I'm here to talk a little bit about how the analytics platform can be a launching pad to help support more advanced analytics. So things that are getting a little bit beyond just a BI tool. Think about predictive analytics, some of these buzzwords, predictive analytics and text mining as examples. So a key first step for most organizations in starting down the path of doing more advanced analytics is taking stock of your starting point. So our analytics team has quite a lot of experience working with organizations, helping to develop and execute different analytical strategies. And so building on that experience and industry standard analytics and data management models, data management maturity models, we have developed our own analytics maturity assessment. And so this is often a starting point for working with a client towards doing more advanced analytics. And this helps us understand and uncover organizational analytic goals, their pain points, the gaps and opportunities that are available to you to do more and to do better with your data. And using the results of these analytics assessments, it helps us work with you to formulate strategies and allocate investments. So in thinking about the additional things that we might do besides just visualizing our data, or really complementary to visualizing our data, in conversations that we've had with our clients, with other people in the public health space, these are some of the key topics that we think are hot and valuable, can add value to our use of data, and those are basic forecasting. So being able to use your historical data to get some idea about what the next quarter or what the next week or what the next month is going to bring for the quantity of services you have to deliver, and doing that in a way that takes care of some of the basic aspects of time series data. So dealing with seasonality and trend, and giving us some idea so to help us with planning and resource allocation. Going hand in hand with that is the idea of anomaly detection. So knowing if the values that we're seeing this month are unusually high or unusually low. This can be because of changes in the context in which our programs are running, or it can be simple data quality errors. So these the main applications of anomaly detection are in data quality and program monitoring. And then another topic that's really, I think, getting a little bit more buzz lately is the idea of text analytics. So we're actually helping one of our clients go through their unstructured data, so text data, and search for COVID-related terms to understand where people are talking about COVID and what they're saying. So text analytics can sort of provide those keyword topics and the lists of what people are talking about, and whether they're talking about it positively or whether they're talking about it negatively. So these are really the key areas that we see, and I want to highlight how the analytics platform can help us with these things. So first of all, forecasting and anomaly detection can really benefit from pulling together multiple data sources, which the AP which the analytics platform can help us with. Additionally, the entire platform is built on top of what's called Amazon Web Services, which is an entire suite of analytics tools and software development tools that is really a great place to develop analytics and to develop tools that do analytics and for plugging in your analytical tools. So this actually, what you're seeing on the screen right now is an example of some work that we've done to sort of do anomaly detection. So the average country level, the average person with country level oversight doesn't have the opportunity, doesn't have the time to look at every single time series for every single indicator that they're monitoring over time. So what anomaly detection helps us do is it allows us to separate out those time series that are unusually high and those that are unusually low. And so that's what we're seeing here. The middle graphic is sort of business as usual for the last quarter that we're talking about. The ones on the right are unusually high. The ones on the left are unusually low. What's important here is using in this particular case, we've used the power of Amazon Web Services AWS Forecast in order to create the predictions for the final quarter and the prediction intervals that have allowed us to segregate these into the lows and the highs. So building on top of Amazon Web Services, really, and having your data there and available is a really powerful thing. And there are a number of different tools that we can use and leverage in order to improve our analytics. This is another example, getting to something that Catherine had mentioned earlier. One of the things that we've done with the data that we've pulled out is we've tried to do some very simple time series analysis techniques to it to make it a little more interpretable and a little bit easier to use. So within the analytics platform, we are automatically, we're creating a new column in our programmatic data that takes this year's quarter minus last year's quarter for the same quarter. So this seasonal differencing allows us to take out these seasonal patterns, and basically then what we're looking at is just the trends. So the data that we're then looking at are trends. What we see here is an analysis that we've done looking at that deseasonalized data. So this is April through June of this year. And the punchline here is these are a number of different essential services by country. And we've scaled the differences from 0 to 1. So 0 basically means it is the lowest, either the biggest decrease or the lowest increase in the history of this data set since about 2017. So what we're seeing right now is a lot of red. And I'm sure most of you on this call probably aren't surprised to see that, given that this is when a lot of countries were having lockdowns or other disruptions of service. So the point isn't so much to point out that, yeah, things are difficult right now. It's that now we're starting to get the information. We can start planning for the catch-up campaigns that we have to have. So having our data all in one spot, having geographic data, we can see the areas that are struggling. We know that there are people that are being missed for vaccinations, for HIV tests, and data analytics are going to help us to know not just where we need to focus our efforts, but the quantity of effort, the quantity of additional effort that we're going to need going forward. So these are the hot topics that we see. These are the ways that I'm trying to use the analytics platform to bring insight to our public health data.
Thanks, Sam. So just to wrap up, BAO Systems, we offer a range of services, products, and want to work with you guys in order to improve your programs. And so there's a number of ways that we can help, and we are happy now to sort of turn it over to questions and answers. And I see that there's a couple of comments that have come in, and also want to point out here that we do have we're on Twitter, Instagram, Facebook, and LinkedIn. So look for us there, tweet, hashtag us, and we will repost anything that you guys have. So thank you.